Hello there, everyone. Thanks for attending our project showcase today. My name is Matt Janzo. I'm the project manager for Team B8. I'm excited to share with you the geospatial and visual analytics solution that our team has developed on behalf of our client, the Washington State Department of Natural Resources. This type of analysis is something that you won't find on any of the other team's projects this year, and we're proud to have been able to offer this solution to our client. Here to provide us with a little background on DNR and this project is my teammate and assistant project manager, Meredith Williamson.
Thank you, Matt. The Department of Natural Resources was established in 1957 to manage state trust lands, including forest, range, commercial, agricultural, and aquatic lands. DNR now encompasses over 5.6 million acres. These lands generate over $300 million annually for public schools, state institutions, and county services, and since 1970 have provided over $9 billion for communities and schools across Washington. Salmon have long been a significant contributor to Washington State's economy and a cherished part of the local culture. In 2011, Washington State Department of Fish and Wildlife reported $1.6 billion were generated from commercial fisheries. Salmon alone are estimated to generate over 100 million per year, and their decline in number have made them a subject of focus and concern for DNR. The Department of Natural Resources sought out the University of Washington MSBA program to assist with gathering and identifying data that support salmon recovery efforts, identify ways to determine the likelihood of a parcel of land being converted, and provide a data-driven model to help predict land conversion. Our scope of our project was to determine the likelihood that an undeveloped parcel of land in Snohomish County will be developed. The FREP and FFF2P are two programs with DNR that will benefit from this land conversion prediction. We intend to use a growth model to provide an analytic solution for DNR. This model will help show how land use is changing over time and allow DNR to reach out to small parcel landowners that may be at risk for converting. We selected a strategic approach to allow DNR to continue this project in the future. For this to be accomplished, we selected an open source data, ensured the model would integrate with DNR's current systems, made sure it could be used quickly, and at no to low cost. The data sources we used were the DNR program data, again, the FREP program and the FFF2P, Snohomish County assessor data, GIS parcel data, and Sentinel-2 satellite imagery. Now to Nitika Raj, who acted as our data analyst for the project for a descriptive and diagnostic analysis.
Thank you, Meredith. So collected data set, we have collected assessor data set for the Snohomish County, and from those data set, we are trying to understand or find any trend or pattern among the features to get initial insights from the data set. So on the left-hand side of the map, we can see it represents the total number of parcels across each city for each property classes. On the right-hand side, we have filtered out the last 4 years parcels which has been sold and trying to identify which property class is the most dominating class among those parcels. So it was found that single family residence is the most dominating class among the parcels which has been sold in the last 4 years. And the overall trend for all the parcels which has been sold in last 4 years, we can see there is an increasing trend for all the property classes. Next, moving next, we are trying to identify what is the change in the average sales value for all the parcels in the last 4 years. So it was found like in year 2019, we have seen there is a highest change in the average sales price for all the parcels. Even for some cases, it has increased from the current market value of the parcels. So we think that average sales value or market value could be a good predictor in predicting a parcels will be likely to sold in near future or not. Similarly, we have identified and we have initial understanding on few predictors and identified few predictors which could be a contributing factor in predicting parcels to be get sold in near future or not. So with all our analysis on the data set and all our understanding, we have created a model in using Azure ML Studio. So here is a quick overlook of that model. So we have created this model in Azure ML Studio using 2-class decision forest algorithm, and we got the accuracy of 93.2% and FN score as a 94.9%. And with a good precision and recall, we can see it's a more than 90%. So okay, so after creating this model, we have deployed this model as an Excel prediction calculator, and we have identified that there are top 8 predictors which are contributing to predict a parcel will be likely to sold or not. So so here the scored label 0 and 1 showing 0 means a parcel will not get sold, and 1 saying that the parcel will be get sold with their respective scored probabilities. So moving on next, I'll hand over to Matt. He'll explain a little bit on our image classification model.
Thank you, Natika. To complement our growth model, we wanted to enable DNR to remotely monitor and observe land use changes easily and with minimal resource commitment. This required us to develop a land use classification model. To do this, we relied on the latest version of the National Land Cover Database, which is from 2016, and this served as our ground truth label data. And we obtained Earth observation data from Sentinel-2. We then developed a workflow in Python, which functions at a high level like this. First, we select a geographic area of interest and obtain imagery and land use data for it. We then prepare the data for modeling by performing any necessary geo-projection and scaling adjustments, as well as cloud removal and other minor corrections. Following these steps, we train our model. We use the 2016 NLCD land use data as our label and 2016 Sentinel imagery in an 80-20 training and test split to do this. This allowed us to conduct our next step, which is training model validation. The validation of the model lets us determine its predictive accuracy and ensures that the prior steps in the workflow were done correctly. And then last, we can visualize the output with the predicted land use classes displayed as an image. So a key benefit of our land use classification model is that it enables DNR to use present day imagery without having present day NLCD ground truth label to go with it. This allows DNR to observe changes in land use without having to wait for the next version of the NLCD data to be published. In this example, shown on screen, we're sending a satellite image from 2019 through the classification model that was trained using images and NLCD ground label truth data from 2016. The model can then interpret the pixels in the image from 2019 without any ground use labels and predict the land use classifications as shown. We evaluated 3 different models as part of our project and determined that the light GBM model was the most accurate with an overall classification accuracy of about 78%. It's a form of a boosted decision tree and has a very fast training time and overall had the best classification of the land use types in our sample data. Here's the receiver operating curve for our light GBM model. What we're seeing here basically is telling us how the model is, how much of the model is capable of distinguishing between the classes. In this case, the land use types. These are shown in that legend to the right side of the screen, and the values in that legend show the AUC, or area under the curve, and higher numbers indicate a better predictive ability for the indicated class. As you can see, our model is very good with water and with the low density developed classes, and less so with the various forest classes. Here's a visual representation of what our model will output at the end of the workflow. On the top left, you see the ground truth label as it would exist in the NLCD data set. The top right is the predicted outcome for the image sample. The bottom left is the differences between the two models, and on the bottom right you see the true color image of the sample area that was put through the model. Next, to talk a little bit about the pros and cons of our model is Megan Tan, who was our data steward and one of the code and programmers on the project.
Thank you. While we take pride in what we've accomplished and think our work will contribute to DNR's efforts towards salmon recovery, we understand that we're working with certain constraints, and there are still a number of enhancements that could be introduced that would bring with them possibilities of greater impact. In terms of the land classification model, one of the challenges we faced was blending data from two different sources with two different resolutions. Being able to acquire imagery at the same resolution would remove the need to scale and greatly improve the vector to raster conversion. Another challenge was that the ground truth data from NLCD was acquired at a specific time, whereas the training data was compiled from a year's worth of satellite images. And one of the strengths of the models is the ability to acquire satellite images regularly. Normal processes require very precise weather conditions, but this model takes a series of images that span space and time, selects the portions of usable data by filtering out things like clouds, and then pastes the images together into a cohesive unit. This does result in some error during the training, as the training labels are not a 100% accurate representation of the image being trained on. Another improvement to the training data would be having a better representation of all classes. The areas we worked with had limited development and were predominantly forest. We also looked to classify different types of forest, such as deciduous and evergreen and mixed forest. If the real priority for identification is purely binary, as in developed or undeveloped, we believe the accuracy of the model would be greatly improved while reducing computational intensity. For the growth model, we chose the best model out of those that we tested. While its predictive ability is high, we still believe that improvements can be made and encourage further testing of various models, such as those available through Urban Sim Library, which factor in real estate development and location. We're also working with a limited data set and believe exploration into additional features, such as those related to economy, population, and legal restrictions, would result in a more robust model. Also, special consideration should be given to feature selection in relation to class representation, as some of the classes in the dataset had small sample numbers. We think that further emphasis should be placed on undeveloped parcels. Here you see the distribution of undeveloped parcels by city. And on the next slide, you can see the 10 organizations purchasing undeveloped parcels. We think that by focusing on what types of buyers result in land conversion, and then looking at the features of the parcels that they're purchasing, we can further identify areas of risk for conversion and give DNR a short list of properties to protect, letting them consolidate their efforts. Matt?
Thank you, Megan. So in summary, some of the main recommended uses for our growth model and land use classification model are on screen before you. We believe that it will allow DNR to identify areas at high risk of development and to prioritize their response accordingly statewide. They'll enable DNR to form smart partnerships with local and regional partners and increase awareness of DNR programs as they relate to development and salmon habitat restoration and protection. We think that they'll allow DNR to inform salmon strategy responses and provide more context in the existing policy environment that they face. And last, it will provide an inexpensive way for DNR to validate the growth model and to gain insight into land use statewide. That concludes our presentation today. I would just like to thank all of you once again for attending and encourage you to reach out to us with any questions you may have or for additional information. You're also welcome and encouraged to connect with us on LinkedIn. Thank you.